Hello, it is that time of month again. It is a stunningly beautiful day here in Edinburgh, and in a few moments we'll be crossing over to Budapest, where it is absolutely sweltering hot, I believe, something like 27 Celsius, for our first presentation of today's broadcast. But first, exciting news that IoTSF will be hosting what we call a plenary event. It's like a mini conference. It will be in London at Westminster's One Birdcage Walk venue, and it takes place on Wednesday, the 3rd of July. It will feature talks, presentations, and panels from our regulatory watch group, our assurance framework group, our smart built environment group. There will also be presentations on SNBD, secure networking by design, NIST, Cherry, and lots more. And best of all, it is absolutely free. IoTSF members can attend all day, and after a buffet lunch, non-IoTSF members can join in for the afternoon session. So go to the events section on the IoTSF website for details and registration. And if you're watching live, I'll put the link to register in the Zoom chat facility in just a few moments. So later in today's broadcast, we'll have special guest Johnny Tyers of ThreatPlane, I should say, who will be talking about how threat modeling helps achieve EU CRA compliance. But first, we go over to sunny Budapest and Attila Szasz of Bugprove, who today is going to talk about firmware vulnerability management, specifically balancing open source versus proprietary code. Attila, the floor is yours.
Thank you very much for having me. Let me bring up my slides in just a minute. And there you should have it. All right. So hi, everyone. I am Attila. This is firmware vulnerability management, balancing open source versus proprietary code. I hope you will enjoy it. So a bit of my background: I am the founder and CEO of Bugprove. We provide a vulnerability management platform for IoT. And previously I worked at Sony, Varia Medical Systems as a security researcher. And in general, I have something like 10 years of experience in embedded system security and R&D. So I have plenty of hands-on technical experience. And I've also done a lot of facilitator work to help product teams understand security. And I'm really passionate about that collaboration. So with Bugprove, in order to contribute back to the security of the IoT ecosystem, we set up a small independent research team in our company that regularly conducts evaluation of popular products. So with this team of 3, including me, we reported something like 50 plus vulnerabilities to more than a dozen vendors, some of that you might even recognize in the past 18 months. So just a quick sneak peek into some of the CVs. Here are some recent ones. Actually, the first one was actually granted just yesterday. The bottom line is that most of these were actually found in proprietary software, and there's a good reason for that, and I will explain that shortly. What motivated this talk? So it's definitely a controversial topic, and we felt like, based on our experiences when we were attending different expos and conferences, is that in the embedded space there is even more confusion. So security researchers like us often argue that open source software offers better security through transparency and community involvement. But this has recently been challenged by the XZ vulnerability in particular, although it had small direct impact on most IoT devices. Whereas we often meet business decision makers in manufacturing who often see code transparency as a bit of a risk compared to due to IP protection concerns. And development teams and like firmware engineers often see open source components and MVD entries as the primary source of vulnerabilities that they have to manage. And they definitely feel the alert fatigue that comes with that. And so we actually want to challenge both of these topics a little bit. And of course, it is impossible to do justice to the subject in 20 minutes, but I have some real-world examples to make up for it. So going back to the basics, I believe there's no perfect security. Okay, you might have some formally validated code in safety critical systems, but otherwise there aren't really perfect code bases. And in this sense, neither open source nor closed software is inherently more secure than the other. But using software composition analysis tools, there were a few surveys and there are some companies collected data on this in the application domain. While in the firmware space, we have some academic papers, but there's less known about the status of that. So in this presentation, some of the opinions here are really just based on my own professional experience, and you are welcome to challenge it during the Q&A. But some of them I'll try to augment with data and case studies. So there's kind of a famous Synopsis report that they do annually. Using their software composition analysis tools, they analyze these more than 1,000 anonymized commercial code bases. And the bottom line is that 84% of these contain some kind of vulnerability, and 74 of them are actually high-risk vulnerabilities. Here you can see that still cross-site scripting is one of the biggest web application app vulnerability type that they list there as the number one CWE category. And we wanted to replicate that for firmware. So as a firmware analysis company, we do have a large corpus of data, both for testing purposes and both to improve our engines. So we also collected something around like 100 of these pieces of firmware, analyzed them and came to more or less the same conclusion. So 79% of them contain high-risk vulnerabilities. The real difference is in the type of vulnerability. So whereas in applications, you're likely going to see those OWASP top 10 cross-site scripting type issues. Here in the world of embedded, we still have a lot of C, C++, memory, unsafe languages. So the main categories are improper input validation, out-of-bounds writes, OS command injections, and buffer overflows, as you can see on this snippet that I included here from our own database. So the usual wisdom is that the real difference between open source code and proprietary software is high resources are allocated to security problems. So in open source, this scales with the importance and the number of contributors of that particular project quite linearly, whereas companies and commercial entities can decide for themselves how they prioritize their spending. So it's really up to their investments, and as you can imagine, this might result in slower deployment in some cases because companies might prioritize patches based on other company schedules. And it also means that they can't rely on the community. They have to have a strong product security team internally or well-trained developers to really address these issues during development. So while proprietary design sometimes rely on security by obscurity, unless there is a sophisticated and deliberate attack on the supply chain, open source code does not really allow for that. So there's an advantage. Whereas security testing can be expensive if you are serious about it, or if you are subject to some compliance requirements that require it. This can be especially hard for companies due to shortage of firmware security professionals. Embedded systems pen test projects cost tens of thousands and scale with the level of security assurance. Whereas in the open source case, we like to think this is free. But this might also be a bit of a fallacy, as this was recently challenged by these supply chain attacks. The mitigation of those are costly, and they get even more expensive the longer they fly under the radar. Finally, closed loop systems have some advantages actually. So over-the-air updates in proprietary are able to deliver proprietary software to different IoT devices. And it can be advantageous in that it is the manufacturer that is able to push the updates when everything is set up well. Whereas in open source project, it's usually the consumer of the library who has to pull the changes into their design. This is different, of course, depending on the distribution. If you're using like a long-time stable distribution, that's nice. Yocto and Open Embedded has their own vulnerability management systems. But if you're using something like Buildroot, and if you have to manage backported patches manually, this can be difficult and be a burden for your engineers. Still, when it comes to bug fixing and community involvement, I believe in Linus's law that suggests that given enough eyeballs, all bugs are shallow, meaning that people can identify and fix issues in general. However, the reliance on volunteers can make it challenging to ensure timely and consistent bug fixes. So I had this very interesting conversation with our lead security researcher just the other day, as he used to be an open source maintainer for a little web-based project. And he was overwhelmed with requests, and he was trying to fulfill those on a voluntary basis, but it was challenging. On the other hand, as a security researcher, he also gets frustrated when he opens a pull request or sends a security fixes that don't get merged or fixed. The XZ case highlighted how a sophisticated supply chain attack can really game this system. So this is something that's being heavily debated now. And this is something that the industry has to come up with a solution for. Also, it is important to note that community involvement is not absent in the proprietary case as well. So external feedback is subject to different disclosure practices, but us as a sort of an independent entity were able to disclose many findings involving proprietary software. But having a VDP, vulnerability disclosure policy, will soon be mandatory, as most of you know. But today things are still behind. And to illustrate this, to see the status of that, I brought 3 examples from our own experience from the past 2 years. So here you can see 3 security disclosures that we participated in. And as you can see, Broadcom and Silicon Labs, as expected from like these big chipset manufacturers, they already have like mature processes in place, mature product security and incident response teams. So coordinating with them was really standard. These 2 issues, a medium severity local privilege escalation and the remote code execution, both of these were fixed within, like on an average of 90 days. Broadcom asked for a little bit of extension, and that's completely fine. Whereas with this other IP camera vendor, Zavio, they didn't have a public disclosure policy available. We couldn't reach them. They were completely unresponsive, unfortunately. And so those issues were never fixed. They coordinated with CISA instead, cybersecurity branch of US Homeland Security. But this meant that CISA had to acquire a working piece of camera from one of the US distributors, then reproduce our test cases, and it was like a 7 or 8 month timeline. So it was really, really difficult to get the advisory out. But now everyone is advised to just replace their cameras because it's insecure if you use these cameras. So on top of vulnerability management, IoT has its own challenges. So first of all, we all know that this is a fragmented ecosystem in terms of technology. So the responsibilities haven't been established. Security is kind of unclear in terms of responsibility. So is it the vendor for the components, the middleware vendor, the chipset vendor? Who should fix the problem? IoT devices often lack updates over time, leaving them vulnerable as they age. So this security longevity problem is also recognized in the relevant ETSI standards and the new compliance regulations asking for at least a five-year security support window. Lack of standardizations. Well, this is an IoTSF webinar. Well, that's why we're here, aren't we? So I think I don't have to go deeper into that. But, you know, security practices, unfortunately, are still a bit inconsistent due to varying standards across IoT devices. Also, there's automotive, medical. There are different sectors with different requirements, and it just can't be stressed enough that tracking security issues is challenging due to the complexity due to the IoT supply chain, and this results in, you know, limited visibility into many binaries for OEMs, and it is the OEM or the router or IP camera manufacturer who's gonna take the liability for the product as a whole, even though for them it's really difficult to peek into those dependencies and binaries if those are not open source. Of course, we are talking about resource constraints devices. So another factor is just the technical limitations of the actual devices. So there's just limited computational power in many cases that restricts robust security feature implementation. I attended RSA last year, and it was an interesting discussion around post-quantum cryptography, which, you know, usually has these very long keys, even compared to like large RSA keys. Sometimes you just can't run those computations on resource constraints devices. You also need to accelerate some of these by hardware anyway, and to have a secure hardware through root of trust, you have to be careful when you're choosing your hardware, ensuring secure firmware updates and device integrity really needs, you know, it has different provisioning requirements as well in terms of, you know, inserting the keys into your bootloaders, your boot ROMs, and so on. And of course, every company is facing competitive pressures all the time, and that's natural. But in the hardware world, this has historically been even more difficult and led to incomplete security testing before product release. And this is something that we definitely experienced throughout our like last 10 years, I would say. And you know, everyone is working on this right now, but navigating the varying IoT security regulations is still complex, and we yet to have a harmonized standard, but hopefully we can say this is being solved now. So one particular practical problem I wanted to focus on for the rest of this talk is a problem we often see, that even manufacturers who carefully manage their open source SBOM, they inherit a lot of proprietary code from the software development kit that they work with. So this can include a lot of things, source code of user space libraries. But even though like these are GPL, like open source GPL components, many of these companies do modifications which are security sensitive. So it's kind of a horror story, and I won't name the vendor. At one time, I saw like a specific DHCP option then received by the DHCP daemon. It was kind of a backdoor implemented into the daemon handling those requests that just automatically executed the command embedded into that DHCP packet. So there's also like proprietary source code and binaries that implement various services, especially kernel drivers and kernel modules. And these are often not mainline kernel modules. So these are of the 3 kernel modules. And again, these are provided via blobs. So you can expect a lot of security issues there. And we will actually just see an example right now. But one problem, it's crucial to mention, is that, you know, these software SDKs are sometimes provided as is, with no commitments to secure SDLC whatsoever. Sometimes it is explicitly stated that the provided software is just example code, but these are still end up being used in production. So a little case study here as well. It was an interesting story. So back then, a while ago, we found some bugs in a Netgear router just using our platform. These were simple buffer overflows, not super critical, but we still notified the vendor. And it was obvious that it was actually the chipset manufacturer, Broadcom, responsible for this code. So we reached out to Broadcom, and they told us that, hey guys, we don't even understand, like this was fixed a long time ago upstream. So like 6 years ago, we fixed these issues. And so it's interesting, but we did verify that Netgear still shipped with this issue in 2023. And so they even assigned an identifier to track this, and they only fixed these afterwards. But we didn't stop there. We actually dig deeper, and we actually found some issues with that within the Broadcom SDK that contained other vulnerabilities. Especially found the kernel mode so-called slab out of bounds write, which is basically a local privilege escalation kind of problem. And then we realized that this SDK is actually probably being used by at least 70 router models from the past, like TP-Link, Asus, Aris, all these devices that I listed on the right. And as you can see, usually, or at least historically, the distribution model for these SDKs was that the SoC vendor just shipped a dev board with an SDK, and there was no agile software mitigation path in between. So this is one of the reasons that could have caused that. Actually, still today, we are not aware of how many of these router models actually backported any of the fixes that we sent. But again, the logistics of this is very difficult as of today, and I believe this is a huge problem. So takeaways and recommendations. So perfect firmware vulnerability management is elusive due to various factors I discussed. Discovering issues in proprietary components inherited from the supply chain requires reverse engineering and binary analysis. And these are capabilities that most manufacturers don't have internally. So they have to hire Pentest labs or consult us if they have the budget for that. Standardization and regulations are very much welcome. This will definitely improve the situation. But I would like to stress again that dealing with open source dependencies and assembling an accurate SBOM is a must, but it is not sufficient for actual device security. And if you have fixes, you definitely should have like a secure OTA mechanism in place. Security patches should be delivered timely. And as sort of a conclusion for takeaways for the industry, so again, the development process should be the focus. Invest in your processes, people, tooling, do threat modeling, risk assessment to get the most value out from those, and build great security teams with strong reputations and contribute back to the community to enhance overall software security. So for example, in context of this XZ vulnerability, I think big tech companies should allocate more resources to support the open source community. We've seen some examples of that recently, and that's very much welcome. So as a closing thought, the collective effort of maintaining security practices can significantly elevate the safety and reliability of both open source and closed software. And thank you for your attention. And it's not time for questions, actually. We will have questions after Johnny.
Thank you for that clarification, Attila Szasz in Budapest of Bugprove. Thank you very much. So not only do we have our smaller plenary event happening in London in July, which I told you about at the start of the broadcast, but we also have the IoTSF annual conference, which will be the 10th edition, and that's coming up in October. Registration is now open. The call for speakers is open as well. And we still have limited sponsor and exhibitor packages available. Go to iotsfconference.com for any and all details. And if you're watching this broadcast live, the link is in the Zoom chat facility right now. Get your questions in using the Zoom chat facility as well, and we'll put them to our guests shortly during the Q&A section of today's broadcast. We've already got 1 or 2 questions coming in nicely. Next, we cross to England, and specifically Bristol, for our special guest is Johnny Tyers of ThreatPlane, and his presentation is entitled How Threat Modeling Helps Achieve EU CRA Compliance. Johnny will show us how established practices such as threat modeling and related assessments can provide the coverage required by the CRA across the product lifecycle, and in doing so contribute to CRA compliance. Johnny in Bristol, the floor is yours, my friend.